All right, well, welcome back. And this is basically what we would do in our first day of a 2-day-a-week class if we were in class. So here we go. I already mentioned to you that I want you to read the overview and look through the syllabus that's on your online 372 course in D2L. Also, in D2L, under the Discussions tab, there is an introduction theme or whatever that I have created. And this is our icebreaker. It has very specific things that it tells you to do. For instance, the first thing you should do is, and I noticed that one person has already done this, congratulations. You should get a picture and upload it into your thing because I want to see who the students are, especially since I can't see you normally face to face. So get me a picture. There are some guidelines. For everything that we do in any of my classes, I say things need to be rated PG, so make sure that you are dressed in a decent manner that is befitting somebody who wants to be a classroom teacher of mathematics. So make sure that the background is decent and all that stuff. If I find something, a picture that I don't approve of, I will let you know. Don't push me. So please just be professional because we all want to be teachers in this class, and I want you to make your best impression as a future teacher. So do that. Follow all the rules, all the instructions there. Okay, then I'm going to load up in D2L my information sheet, and this is something that I do every semester. It allows me, if you use a different email, for instance, than what's in your Leo mail, feel free to put it on there. Phone numbers so that I can contact you, and former teachers and classes and stuff like that. Just some basic information that I want to know about you. But the big thing here for me is for you to put any special information, and it's in there. Of course, I picked up a pen that doesn't want to write. Special information. So if you have something that I need to know about you, for instance, one time in a class I had a student that walked in and she was 9 months pregnant and she was going and I said, get out. So I clearly knew she was pregnant, but she came in that day. We had an exam, and she just had to take the exam. And she was like, I'm going to be okay, I'm going to be okay. And I said, no, you're going to be okay in the hospital, babe, because you're out of my class. So I jokingly tell people, don't go into labor in my courses. But if there's anything that might keep you from being at your best behavior, so to speak, in our course, like if you know that, I don't know, you have a cruise planned for the week of Thanksgiving, so that might interfere with test 3, then you need to let me know those things early. Anything that might affect your performance or anything like that in class. Okay, the next thing, you have, as of today, your first project. It will be due in 1 week, so I'm going to make everything due on the Mondays. That'll give you like a full solid week. I'm going to try to have everything always posted on the Monday of the week, and that'll give you a week to get things done. Now, I know that September 3rd is Labor Day, but technically A&M Commerce is open that day. We just aren't having any classes. But if you don't want to be messing around with stuff on Labor Day, it's due on Monday. That doesn't mean that you have to do it on Monday. Please, if you want to enjoy your Labor Day, send this in to me by Friday. That'd be great of this week. And that way it's just off your plate and out of the way. So same thing with this information sheet. September 3rd, it's a Monday. So go ahead and get those things into me. Your first project, what you will be doing is you will send me an email. And in that email, you are going to give me what you consider your math biography. So I tell people their math biographies are basically your experiences in math until this time. So most people want to be a middle school math teacher. They probably had some pretty good experiences, but just whatever you've got. I want to know why you want to teach math. And I want to know what your goals are in the classroom as a teacher. So why do you want to teach math? What are you wanting to do with it? That kind of thing. Some people might want to be a curriculum instructor, the curriculum coordinator for their district, or some people might be just really happy to just be a classroom teacher forever. So those are the three things. So you should give me your math biography, why you want to teach math, and what are your goals in the classroom right as a teacher. And those should be, that together should give you a pretty good sized response. So if you send me one sentence on this, I'm likely to email you back and say you haven't completed the project. So at least one or two sentences on each one of those should make you a pretty good paragraph or a page, half a page, whatever. But 1, 2, 3 sentences, and I'm likely to send that back. So that will be your first project grade. The good news about your first project grade is it's either 100 or a 0. You either did it or you didn't. So you're going to get credit for this or not. And it's just sending out an email, so you might as well do it. Just get it off your plate and get a free 100 in the thing. Get it done. So that'll be great. Okay, number 5 is read the introduction and the chapter 1 in Fostering Algebraic Reasoning book. So just go ahead and start reading on that. If you have problems with your textbook, getting the textbook or something like that, then let me know. But most people, within a week of starting school, you should have that read and you'll be all right. Okay. And then the last thing that we would normally do in our first class would be the locker problem. I love starting this class with this. It allows us to just be active and just be doing some math, some algebra. So the locker problem is indeed in your book. If you look on page 10, you will see the locker problem. I have it in a different format here, but you can dig it out. Plus, I'm going to load this particular page up into your D2L, so you'll be able to see it. So here's the locker problem. In Washington Middle School, there are 1,000 students and 1,000 lockers, and they are all shut and unlocked. Each year for homecoming, the students line up in alphabetical order and perform the following strange homecoming ritual. Number 1, the first student opens every single stinking locker. Number 2, the second student goes through and closes every other locker. So they close the second one, they close the fourth one, they close the sixth one, and so on. The third student goes through and they call it changes the state of every third locker. Okay, beginning with number 3. So when they say change the state, why do they say change the state? Think of that for just a second. Okay, and this is going to be our first opportunity here in a minute. I'll let you pause the video and you can do some stuff on your own. So what I do, and so on and so on and so forth. 4th person, 100th person, and so on. So what I do with this one generally in the classroom is I'll just use what we call 2 color counters. Hopefully you've seen these before. They're just little discs. And I'll lay out a bunch of them, so that's 6. And these are going to represent the lockers, and we'll start with, of course, number 1, number 2, number 3, and so forth. So here I go. I'm just going to throw a bunch of them up here. And we will work through kind of what does it mean that they're telling me, and why are they using that weird changes the state term. Okay, that's weird phraseology there. All right, so here are all my lockers. What do I have there? I have 14 of them. That's great. That'll work out wonderfully. So we have 14 lockers. They have 1,000. We're just going to do, if you've ever taken one of our math education classes, which most of you should have, there's something in Math 350 that we call work a simpler problem, right? So I'm just going to work 14 of them. Then you can deal with 1,000 later. All right. So let's say that they were all closed. By the way, if you don't know what a two-color counter is, on the other side, they're a different color. So they were all closed and unlocked. That was red. This is after, let's say, student number 1 goes through and opens them all. So yellow is open lockers. So now that student 1, so I'm going to make myself a little note here so I remember. Yellow is open lockers. Red is closed. By the way, if you don't have two-colored counters at home, which I don't imagine many of us have those just sitting around, you could make your own two-sided object. So for instance, you could just take a regular old sheet of paper and rip it up in, or well, color one side or make it into grids or whatever on one side and leave it blank on the other side, and rip them up. You could put X's on one side, whatever. As long as there are two sides of the paper and one side is one way and the other is the other way, yours could be blank paper and grid paper or whatever. So you can just do that. There's other stuff that you can do to kind of make your own cheap, inexpensive, at-home types of manipulatives. So here we go. Everything is open. Student 1 has gone through and done their mischief. So now I need student 2 to go through. So student 2 is going to flip, close, locker 2, locker 4, 6. They're not going to touch 7. They're going to flip 8, 10, 12, and 14. So now student number 2 has gone through and closed every other locker. All right. So now take a second and think about it. What do they mean when they say changes the state of every third locker? So what I say is, well, that means, because now there's kind of an even odd thing going on, right? So multiples of 3 would be 3 and 6, for instance. And 3 is open and 6 is closed. So I'm going to change the state. If it's open, I'm going to close it. And if it's closed, I'm going to open it. So that's what they mean by changing the state. Okay, so 6, 7, 8, 9. I'm going to flip 9. Now it's closed. 10, 11, 12. I'm going to reopen that one. And if I had a 15th locker out there, I would flip it, right? Actually, let's go ahead and stick a 15th locker out. This would be open from number 1. We would have ignored it for number 2. And then the third guy would have closed it, right? 15 will be nice. Let's do that. It'll give me some nice stuff in a minute. Okay, so that's the third person. So my thought is this. Whenever I look at this problem and I start thinking about what the heck are they doing here, I tell students, well, maybe start thinking about what you think is going to happen, for instance, to locker number 1. Notice we haven't touched it since that first guy went through. So think about it for a second. Are we ever going to change the state of locker number 1 now that it's been opened? Will the fourth guy touch it? Will the fifth guy touch it? No, because they're just going to all start where they are, right? So the fourth guy is going to start right here. He's never going to touch number 1. Will the fourth guy touch number 2? Number 3? No. So interesting thing, whenever the fourth person comes through, we know that locker 1, 2, and 3 are not going to change their state anymore. So let's do that. 4, he's going to flip 4 around. Now it's open. 5, 6, 7, 8. I'm going to flip that guy. 9, 10, 11, 12. I'm going to flip that guy. 13, 14, 15. If I had a 16th one, I would flip it, but there's not. Okay, so now the fourth locker is done. Kind because 5's not going to touch him, 6's not going to touch him, right? So he's always and forever, the 4th locker is going to remain open. So let's go ahead and do the rest of them. 5's going to flip. 6, 7, 8, 9, 10 is going to flip. 11, 12, 13, 14, 15 is going to flip. That's why I did him. Okay. So 5 is done. Go ahead and take a second and do your own. 6 is going to flip, and then the 6th guy is going to also close or change. 7, 8, 9, 10, 11, 12. In this case, it's opening the 12th guy. Okay, so now I've gotten rid of all the things that are times 2 here, right? Because 6 times 2, oh, no, 4, 7. 7's going to change 7 and 14, right? But 8 can't change 16 because I just don't have it there. But if 8 did, then he would change himself, and he would change number 16. 9, flip. 10, flip. 11, flip. 12, flip. 13, flip. 14, flip. 15, flip. Okay. Oop, I can tell that I made a mistake in here. That's okay. So, you'll figure out why I made a mistake. I must have gotten too carried away. So I'm just going to get rid of those right there. Okay, so, oh man. Okay, I'm going to do it again. I'm going to pause the video, and it's going to come back up, and it's going to be okay. Give me a second. You can do it too, and then we'll compare. How's that?